Most times in electronics, there is need for a large voltage circuit to communicate with a low voltage circuit. To prevent spikes in high voltage from kabooming the small circuit, you need isolation. The most common way to do that is using a transformer, but it adds much weight. That's where we get to use an optocoupler. Let's go back to the year 1910, when war was all over. Ships stopped using radio comms and started using light to send Morse code to neighboring ships. One ship would light up a beam in a coded sequence, and soldiers on the other ship received that signal and converted it into actual commands. The optocoupler is just a scaled version of that same mechanism. It receives current on the primary side, which turns a light-emitting diode on. That light then activates a phototransistor on the opposite side, which allows current to flow in the secondary side. When the light received increases, the current flowing also increases. This is always represented by the current transfer ratio. So basically, what you're seeing here could be an optocoupler. It makes sense, but in real application though, the LED and phototransistor are very small. The LED produces infrared light instead of visible light. So to the naked eye, most optocoupler LEDs don't show any light. The space between the LED and phototransistor is filled with transparent epoxy, which allows infrared light to easily move from the LED to the transistor. When you actually take a good look, the really important parts of an optocoupler are too small compared to the metals holding them. It's just like all these big metals are just humbly sitting there waiting for the small ones to command them on what to do. That's how unfair the world can be sometimes, but anyway, we are learning, not beating. The current flowing at the transistor side can always be magnitudes higher or lower than the current flowing into the diode, and this depends mainly on the nature of transistors used. In critical designs, the PCB section below the optocoupler is cut away to provide extra isolation. These devices are used in laptop chargers, washing machines, electric vehicles, solar inverters, and many other appliances. Without these isolators, most of your gadgets at home would have been fried long time ago. Hope you learned something from this video. See you in the next video.